All right, guys, we're back at it with part 2 out of 3 for ellipses. We are now going to talk about a focus. Well, really plural because an ellipse actually has 2 of them, so we call them foci for plural. All right, so ellipses have 2 foci, and there is a simple formula in order to figure them out. If you remember with parabolas, we studied a formula 1 over 4a in order to find the focal distance. Well, here, in order for us to find the distance to the focus, or to both of them, to the foci, we're going to use another simple formula, and it kind of reminds me of the Pythagorean theorem. This formula is a squared minus b squared equals c squared. So it's the Pythagorean theorem, but subtraction. It's actually rather simple. Now, in order to make this work, in the previous video, I said that this was x over a squared, and that the 16 is in the place of the b squared. In reality, if you think of it this way, you can just use your major axis and call that one your a squared. So you can really subtract these. When you're going to subtract 2 numbers, you usually like to subtract the smaller one from the larger one. If you do this backwards, it'll still work out as long as you remember to use a positive. Let me show you what I'm talking about. All right, if I'm going to use my focus formula, then I am going to take my a squared and subtract my b squared. Well, my a squared in this case is going to be 16, right? That is in place of where the a squared goes. If you remember the previous video, you might say, well, that was b squared, but I'm telling you, you can use them interchangeably as long as you're using a squared to represent the major axis. So this is 16 minus 9, all right, equals c squared. So 16 minus 9, last time I checked, was 7, all right? So 7 equals c squared, and if I take the square root of 7, that is going to be my value c, all right? My value c is the square root of 7. Okay, and we're actually going to leave it like that. The square root of 7 should probably be 2 point something another, but we're going to leave it as square root of 7 just to have an exact quantity. All right, now, if you remember with parabolas, that c value, that was a focal distance, and we used it to go from the vertex out to the focus. In this case, we're not going to travel from the vertex. Instead, we're going to start at our center. All right, so we're going to start at our center, -2, 3. All right, and what we're going to do from the center, -2, 3, is we are actually going to go up square root of 7 units and down square root of 7 units. So it goes without saying that the foci are actually always going to be located on the major axis. Okay, so again, we go up square root of 7 and down square root of 7, which naturally is not going to change your x value, but it is going to change your y value. Let's see what that looks like with coordinates. All right, so we are, again, going to add, and I know I used decimals right here, but let me take these guys away. All right, so I am going to travel from -2, 3. All right, and let's get started. So my first foci will be at, again, my x is not going to change because it's on the vertical major axis. My 3, though, I'm going to add the square root of 7 to it. All right, so I am actually just going to leave it like that, 3 plus root 7. If you want to change that to a decimal, that is up to you. All right, and then I'm going to enter another coordinate, which is going to be -2, 3, which is my y coordinate. But now I subtract the square root of 7. All right, and that, let me erase some things. That should leave me at both of my foci. And see, you can let Desmos give you the decimal for that. You enter the exact one. So those are the exact coordinates of the foci, right? Foci are the focal points of this ellipse. Okay, so again, just to recap, to find these foci, we use a squared minus b squared equals c squared. So we subtracted our denominators to give us c squared, took a square root, and that was going to be our focal distance. So to find the actual coordinates, from the center, we traveled square root of 7 units away along the major axis. Again, I don't want you to think that this is always going to be along the vertical axis. This is along the major axis. So we went root 7 units above the center and square root of 7 units below the center, and that led us to find our exact coordinates for the foci. All right, you notice that just using the denominators are already in squared form, so you can really just find their difference and then take a square root. Okay, that is how you locate the foci of an ellipse, and now you should be set with everything that you need to know about an ellipse in standard form. The next video is going to go over general form, so stay tuned.